Hello, and welcome to our interactive stargazing for tonight. My name is Ariel. I'm an educator here at the Lowell Observatory. So tonight we'll be using our 17-inch plane wave telescope. We'll be able to jump from object to object. I'll be talking about these objects and we'll be showing them on the screen. And if you guys have any suggestions or anything at all, we can totally try to look at these objects for you. Now, today, June 30th, happens to be a special day. It is Asteroid Day, initially founded in 2014 by a group of incredibly bright people, including my personal hero, Brian May, who happens to be the lead guitarist of Queen, as well as an astrophysicist. Brian May has visited our very own campus and has looked through our historic Clark telescope. So to start off, we will be looking at the asteroid Themis. The way we'll be looking at this guy is thanks to our Lowell astronomer Nick Moskovitz and his team. He's created this asteroid finding program, and if you're an amateur astronomer who would like to find some asteroids yourself, we can totally put the link to this program in the chat later on. So the way we found this asteroid is through this program, plugging in the right ascension and declination, kind of like the spot in the sky where this object is. We took this information and put it into our Malincam software, and now we are able to actually see the asteroid Themis live. So right in the center there, we see the asteroid Themis. Themis is actually kind of cool. It was discovered in 1853, and it is one of the largest asteroids in the asteroid belt, with a diameter of about 200 kilometers across, or about 120 miles across. The reason why it's kind of neat is it appears that there is water ice completely covering its surface. And as the ice layer is sublimated, or as the ice layer goes directly from a solid state to a gaseous state, it may be replenished by some ice reservoir under its visible surface. So we're seeing a live photo of the asteroid now, but it doesn't quite look like it's moving because it does take some time for this asteroid to move. But what we can do is we can actually jump back over to our little asteroid finding software and see within a 2-hour period where this asteroid will go and where this asteroid will move. The asteroid belt is between Mars and Jupiter. It's a group of planetesimals that formed when the solar system was first forming. Asteroids, move relatively quickly, but we're able to see, again, that whole movement of that asteroid using that program. So the next object that I would love to look at is pretty stellar, even though it may not look it. We will be looking at a galaxy with an active supernova that has become visible just this week. We will be looking at the galaxy M85. So M85 is an elliptical galaxy located in the Virgo cluster, which we are also a part of, so this big old galactic neighborhood. You'll also notice on the screen there that we see these stripes going through the screen. The reason why is because we're taking long exposures of these objects. So right now we're taking a 5-second exposure. And as we move the telescope, as you could see, on the screen earlier. And as we're taking an exposure at the same time, it kind of looks like we're going light speed towards the other objects. So it's not shooting stars or anything. It's just that we're taking a picture while we're moving the telescope. Now in this object here, right in the center, we can see the nucleus of the elliptical galaxy. So that the center of that galaxy. And just below it, you'll see what looks like 2 stars. However, that center star is actually a supernova. So what a supernova is the death of an incredibly massive star. So we'll have stars millions of times larger than our own sun. And what will end up happening is over the course of a couple billion years, this star will use up all of its fuel. And once all of that fuel is used up, that star will explode. And since this is a larger massed star, we actually get heavier elements out of it. So all stars are these little element factories. And a supernova will give us heavier elements like iron and gold and that sort of thing. So if you're using a gold or wearing a gold ring, that gold was formed from within a supernova. Now, this galaxy is about 60 million light years away. Now, a light year is a very long distance. A single light year is about 6 trillion miles. Now, it's like, okay, 6 trillion, that's fine, but a trillion is a big number. Like if you were to count to 1 million, like 1,000, 2, 1,000, it would take you 11 days straight. If you were to count to 1 billion, it would take you 32 years. And if you were count to 1 trillion, 1/6 of a light year, it would take you 32,000 years. So a billion mile or a trillion miles is a lot of miles, and 60 million light years is a very, very long distance. That also means that we are actually time traveling. By looking at this object that's 60 million light years away, we are looking 60 million years into the past. So even though this object just became visible to us this past week, it actually exploded. The supernova went off 60 million years ago. So the next object that I would love to grab is actually the moon. Now, the moon is pretty bright tonight. I believe it's like a waxing gibbous tonight. So really dim objects, if you guys would like to look at them or request to look at them, we can absolutely try. But since the moon is so bright, they might be a little hazier than usual, but we'll still be able to get them okay. So we are jumping to the moon. It's incredibly bright. With the moon and how bright it is, we actually don't take as long of exposures as we did for that galaxy or the asteroid earlier. Since it's so bright, it's basically like we're just projecting a video on the screen right now. So very, very short exposure time, a couple milliseconds of exposure time. So looking at the moon here, or even when you look at it with your naked eye, you'll see really dark patches on the surface. Those dark patches are called maria, and that's actually Latin for ocean. There's no oceans on the moon right now. The reason why those are there is way back when the solar system was first forming, all of this stuff was crashing into the surface of the moon. All of these space rocks were crashing into the surface. And at the time, 4.5 billion years ago, the moon was covered in effusive volcanic eruptions. So really slow magma flows and lava flows. So that molten rock filled in these impact craters, and that rock hardened a darker color than the rest of the surface. So we see all of this maria facing our side, and actually on the far side of the moon, which we just can't get tonight or ever on Earth, has a lot less maria because the moon kind of acts like a little shield for Earth. So the moon is tidally locked with us, meaning 1 lunar orbit equals 1 lunar rotation. So the same side of the moon will always be facing us. So rather than the dark side of the moon, it's more so the far side of the moon. So since the moon is tidally locked with us, the same side will always be facing us. So the moon kind of acts like our shield, and we almost act like a shield to the moon, where all of those little space rocks will be hitting the other side of the moon, and they'll actually break off the maria on the far side of the moon. We have gotten images of the far side of the moon with satellites and that kind of thing, but not right now. We can't show that right now. We can see the Apollo 11 landing site right about here. Apollo 11 landed there a little over 50 years ago. I guess it'll be 51 years next month. Wow, that's wild. Now, the Lowell Observatory actually played a very big role in the Apollo landings and the lunar landings. Back in the 60s, our historic Clark telescope was recruited by NASA to map the moon for the Apollo missions. So most of the Apollo astronauts that have stepped foot on the moon have looked through our Clark telescope. They'd also do a lot of studying or practicing in northern Arizona. Like they'd go to Meteor Crater and walk around in their spacesuits, or Sunset Crater. Like, could you imagine being a tourist and seeing a bunch of grown men playing space cowboy? Like, I love that. I think that's so cool. Now, you might notice in the view that the moon almost looks like it's shaking or moving a little bit. That is actually because of our atmosphere. So we do have this whole big old atmosphere covering Earth, and all Earth-based telescopes will get this atmospheric interference. So that'll make things look like they're shaking a little bit, might make things look like they're blurry depending on the wind and that sort of thing, or how low it is in the horizon. If an object is very low in the horizon, you're looking through a little more atmosphere, so something might look a little blurrier or fuzzier. You can actually see this with your naked eye as well. If there's a very bright star rising in the horizon, like rising in the east horizon at night, it'll look like it's having a party, like having, you know, a bunch of different colors you'll see. It's not that the star is actually changing colors, it's just that atmospheric turbulence that we're seeing there. Now, the next object that I would love to look at is M27. Now, M27 is a planetary nebula called the Dumbbell Nebula. We're going to see if we can get this in view. Now, planetary nebula the name is a bit misleading. There's no actual planets involved. It's just when we first discovered these objects, the astronomer that found them believed, oh, nice, he's in there. Oh, little ghost guy. The astronomer that first found these objects believed that in the center, he was seeing a planet, and then he was seeing gas on the outside. So he called it a planetary nebula. Now, what's actually going on there is we have the death of a sun-like star. So that little dot in the center there, you can actually see, like right in the center, is a white dwarf. And that white dwarf is what our sun's going to become in a couple billion years. So what ends up happening here is we have an average star, so a star like our sun. That star forms from thermonuclear fusion and then lives its life burning its hydrogen fuel. And once there's no more fuel left to burn, similar to a supernova, that star will explode, that star will die. But since the sun or these average stars aren't as large as these supermassive stars that create supernovae, we actually get lighter elements. We get elements like helium and oxygen and nitrogen, these lighter gases. So in this object, or in this image, we can see, let's do this, the white dwarf in the center. Is this working? Uh-oh. Nope, it's not. Sorry. We can see the white dwarf in the center, and then we can see that those lighter gases coming outwards. And the different colors of gases the different colors are different gases. Claire would love to look at M4. Can we try to grab M4? I believe M4 is a glob. Yes. So since we started slewing the telescope while we were taking exposure, you can just barely see those little stripes in view. Yeah, cool. Oh my goodness, Messier 4. Okay, so this is a globular star cluster about 7,000 light years away. So again, we're jumping 7,000 years into the past. Globular star clusters are very interesting. These guys are some of the oldest objects in our galaxy as well as our universe. So these globular star clusters form from these giant molecular clouds called nebulae, or a nebula. And globular star clusters usually have hundreds of thousands of stars within them. So there's a great deal of stars in them, and there's a lot of mass. So all of these stars kind of glob together. So we see like kind of a denser concentration of stars in the center, that center of mass. So these stars glob together and they stay globbed, and they kind of like orbit about each other like a tiny little dead galaxy almost. Globular star clusters are also incredibly old. These are some of the oldest things in our galaxy / universe. Usually these guys are like 11 billion plus years old. So, okay. Now, can we try M104? We're going to see if that guy is in view. He is. He should be in view. M104 is one of my personal favorites. Oh, gosh. He is the Sombrero galaxy. So when we talk about galaxies, there are different types of galaxies, different kinds of galaxies. The reason why the screen actually went white is because we moved in front of the moon while we were taking an exposure. So it's like way too bright. We took way too long of an exposure. Wow, he looks awesome. Oh my goodness. Okay. So the Sombrero galaxy is about 30 million light years away from us. And when I was talking about types of galaxies, the main types of galaxies we have are spiral galaxies and elliptical galaxies. The galaxy that we were looking at earlier with the supernova, the M85, that was an elliptical galaxy. What that means is that there is less star forming going on. There's less gas, there's less nebulae, there's less active star forming regions. So it looks more so like a little smudge in the sky. Spiral galaxies are younger galaxies. I mean, like still like a couple billion years old, young in a galactic sense, I guess. Uh, but these spiral galaxies and galaxies like spirals, they have a lot of star forming regions. So that dust lane that we can see in the front here, we have a lot of gas where star forming regions are and where star forming is occurring. You can also see the really bright galactic nebula in the center there. So M104. We can see Jupiter. We thought he was going to be a little too dark, but we can grab him. Now, looking at planets with this guy is a little funky. It's the same thing like with the moon, where we don't take that 15-second exposure that we see like with the Sombrero galaxy. We usually do an exposure for a couple milliseconds. Oh, he's nice. So we're messing with the gain right now, so we can actually, oh wow, oh he's coming up, that's so cool. So we can actually get some of those stripes on the surface of Jupiter. Down the gain a little, yeah. Oh, okay, so we also have one of the Galilean moons. Oh, two of them. Oh, how nice. Okay. So these are two of the four largest moons of Jupiter. There's Io, Europa, Callisto, and Ganymede. Not completely sure what those two are. They're either Io and Europa or Callisto and Ganymede or a mixture of two out of the four. Now, those aren't the only two moons of Jupiter. Jupiter has over 80 confirmed moons. Since it is like right past the asteroid belt, Jupiter tends to suck in a lot of those asteroids a lot of the time. So even though they're very small moons, or they can be pretty small moons, they still count as moons. One of Jupiter's, oh nice. One of Jupiter's moons is actually larger than our own moon. So looking at this picture here, we can see those stripes on Jupiter's surface. We also see some of that atmospheric turbulence, but we can still get a pretty good view of them. Those stripes are different gases. So we see primarily hydrogen gas, helium gas, and ammonia ices. So those lighter stripes on Jupiter are primarily helium gas and ammonia ice, and those darker stripes are helium gas that's kind of lower in Jupiter's atmosphere. Jupiter is a gas giant, so there's no actual surface to him. There's just gas and then denser gas and then gas that's so dense it becomes metallic, and then maybe like a super tiny rocky core. Yeah, those helium lines are lower in the horizon or lower in the atmosphere, and they get direct exposure to sunlight. So the helium or the hydrogen lines are basically Jupiter's tan lines because they don't get protected by the ammonia helium clouds. Now, Jupiter. We are trying to jump to M8. Ooh, okay. Yeah, let's do the Lagoon Nebula. So I really like the Lagoon Nebula. This is one of my favorite objects out of like the 20 of my favorite objects in the sky. So the Lagoon Nebula is a very large star forming region. We are taking a longer exposure right now, but in a couple seconds, we will actually be able to see all of the gas in the Lagoon Nebula. So right now we're taking a 10-second exposure. You can see that bottom line in the screen there. Wow, oh, you're so cool. I love it. Okay. So the Lagoon Nebula is an emission nebula and a reflective nebula. So in the center there, or most of the stars in the center there are baby stars or protostars. What's going on is we have this giant cloud of primarily hydrogen gas. The universe is like 90% hydrogen. There's a ton of hydrogen. We're messing with the gain and exposure right now so that we can get a pretty good view of the nebula. But we start off with a very large cloud of gas nebula. So we can see here fairly well the Lagoon Nebula. We can see all of those gaseous regions. And what happens is over time, this gas cloud will break up into smaller gas clouds. So they'll break up into smaller gas clouds, and through gravity, these small gas clouds will compress and condense, and all of these hydrogen atoms will fuse together, and more atoms are getting denser and hotter and fusing together, and then we get a protostar, or we get a baby star. So a nebula like the Lagoon Nebula has enough mass and energy to form like tens of thousands of sun-like stars. So this little nebula is a little stellar nursery. You'll see off to the left-hand side, there's more of a kind of like a red gas, and to the right-hand side, there's more of a bluish gas, and that's just a result of the nebula being reflective. So we should jump over to the Trifid Nebula as well. Or is this guy the? Yeah, perfect. Okay. So the Trifid Nebula, I believe, is a reflective nebula as well. I believe those colors might be a little more noticeable. Just about. Okay, cool. Oh, this is nice because you can see the dark nebula as well. So what's going on here is, again, we have this star forming region. You can see like that red gas and that blue gas, or that pinkish gas and the purple gas. And right in front of this really bright star, right about here, you can see what looks like absence of light. What that is it's just the gas that's forming those stars in front of those really bright protostars. So all of those baby stars that are being formed in the center, that gas is kind of crossing over them, making it look like a darker area. But that's, the same gas that we're seeing lit up in the background, that same red gas, it's just a little darker. We kind of saw the same thing almost with the Sombrero galaxy. Now, the Alan Santana requested the Umbrella Galaxy, so NGC 4651. I don't think I've ever seen this guy, but I would love to see him. So NCG 4651. Now, when we say things like Messier 8 and NGC, those are different catalogs that we use. So the Messier are the kind of like the first objects that were really like officially cataloged, the Messier catalog. There's M1 to all the way to M120 something. So we have like those really popular objects like the Sombrero galaxy or the Andromeda galaxy is M31. The Crab Nebula is M1. So those guys that we hear about a lot, the guys that have the really cool names, usually are a Messier galaxy. Some of the NGC objects also have really cool names. NGC stands for New Galactic Catalog. So these might be objects that are a little more difficult to see. So like this guy's the Umbrella Galaxy, and wow, that is neat. So we can see the spiral arms there. So like those nebulas that we were seeing in our galaxy, there's the same thing happening there. That S shape is where all of this star forming, all of these star forming regions are. And we can see that really bright galactic nucleus as well. Now, I see that Nico Adams asked how large the telescope is. We are using a 17-inch plane wave telescope. So it is a reflecting telescope, and it is up at our Giovale Open Deck Observatory on our main Lowell Observatory campus. It was just installed or started being used at our campus last year, so it's kind of like a newer scope. Our whole Godo Open Deck Observatory is a new facility, so it's real fun to use. So the Eagle Nebula, we should jump over to the Eagle Nebula. Now, the Eagle Nebula, I like a lot. I think it's really cool. I believe the Eagle Nebula is where like the pillars of creation are. So like one of the most popular Hubble photos you've probably seen it. If you don't know what I'm talking about, you've probably seen it and not have known. The Eagle Nebula, again, is a star forming region. So we're jumping on over to the Eagle Nebula right now. What we'll see is we'll see that dark nebula. So again, that gas that's kind of covering those stars, as well as an emissive nebula. So we'll see those protostars. Nice. We'll see those protostars that are lighting up the background. So you can pretty clearly see it's kind of like upside down from where you may have like seen it before. But you can see those really bright stars that are kind of illuminating the background almost. So we can see that hydrogen gas, that red gas in the back, and we see the pillars, though those really dark nebula areas right behind it. That's cool. Wow, I like that. Can we get a picture of that real quick? I want to see it later. um, Now, I see a question from Dallas. Can we see Pluto if it's visible tonight? We cannot see Pluto tonight, but I believe we do have images of Pluto that we've taken previously. So how we can see Pluto is he up tonight actually? Wait, no. I believe we do have images that are saved. Oh wait, he is up. Okay. So the issue with Pluto is he's tiny. He's very, very small. Uh, he's actually like if you took Russia and put Russia into a sphere, that's about as big as Pluto is. So this field of view that we see right now, Pluto is in there somewhere. But the fact that he is so small and 4 billion miles away makes it very hard to see. Now, what we've done previously is we've taken images of Pluto, and what we can do is kind of what Clyde Tombaugh did when he first discovered Pluto, is we can kind of blink compare these images. So what you'll see are two images that are of the exact same field of view, the exact same star field, and you'll see, I believe you can see my mouse here, right about here. You'll see as we go back and forth, these images were taken just a day apart. Let's do this then, maybe here, right? Wonderful. Oh no. So again, taken 2 nights apart, nice. We can see how this tiny little dot moves just that much, and that tiny little dot is Pluto. So we grabbed him. Now, Pluto. That's actually how we found Pluto, like that blink comparator or that blinking of the pictures back and forth is how we find asteroids. Kind of like the same way that change in distance over a period of time is how we're able to find objects like it. Objects like it. M57. Haley requests it. Hi, Haley. I believe M57 is the Ring Nebula. This is an object that I like a lot. The Ring Nebula is another planetary nebula. So it's like the color of the Ring Nebula compared to the other planetary we looked at, compared to the Dumbbell Nebula. It looks like a little like brighter to me. I don't know. But we're seeing the same thing here where the white dwarf is in the center there. That dying star is expelling out all of the gases that it's created throughout its lifetime. So we can see that. Oh, nice! We can see that red nitrogen gas on the outside. We can see like the teal oxygen, kind of that thicker ring, as well as the helium in the center there. Sorry, the red hydrogen on the outside, and then the oxygen in there as well. The Ring Nebula is about 2,500 light years away. So again, we see the death of a lighter star, so we're getting those lighter gases in there. So Allie from Tucson asks to see the Helix Nebula. Let us try to grab the Helix Nebula. Oh, he's actually not up yet. We might be able to grab him later on. I will keep you posted. Alpharats, we would love to see, but he is also not up. The Helix Nebula actually won't be up this week, but at a later interactive stargazing, we may be able to grab him for you. Right now, he's in Aquarius. So if anyone has any other requests, feel free to ask them. If not, I would love to see. Ooh, let's look at the Veil Nebula. So, way back when, a year ago, when we first we're like trying this program out, first really learning how to use this. One of the first objects that I saw was the Veil Nebula, and like, oh, it just looks so cool. It just looks so neat to me. Um, we might be able to grab him. It reminds me of like Spider-Man. So just barely, we're gonna up the exposure a little bit, and we're gonna try to see the gases in this nebula here. So we're gonna try to see this guy come in. And then after, yeah, so just barely, he's coming in. Maybe the wind might, yeah, we might up the contrast a little bit. I don't know about the gain, but yeah, okay, cool. Yeah, so he's just barely coming in. It might also be the moon again is pretty bright tonight, so the sky might look a little lighter than usual. But we're seeing again all of that whole star forming region that really expands almost across the whole field of view. It's a little bright out tonight, so we're not able to get it in as vivid of detail as it usually is. Now, binaries. So I love binaries. I believe Albireo is up tonight. So we should, yeah. Oh, okay. So yeah, you can just barely see kind of like that gas going through. So binary stars make up about 60% of the stars that we see in our night sky. What binary stars are two stars that have a very strong gravitational pull to each other, so they actually end up orbiting each other, creating a binary. They're also trinary. There's 3-star systems, there's 4-star systems, all the way up to like 200,000 star systems, and those are globulars. But anyways, Albireo is a really nice binary. So when we're viewing Albireo with our naked eye, it looks like a single star. Albireo is the head of Cygnus the Swan, but looking through telescope aid, you can actually see that there's 2 stars that they're just really close together. Albireo is about 450 light years away with a 215-year period. So it takes about 215 years for those 2 stars to go around each other. And the reason why one looks a little redder than the other one is actually because of the temperature difference. So brighter stars in the sky usually appear more white or blue, and cooler stars appear more red and yellow and orange. Those warmer colors are cooler stars. So your faucet companies have been lying to you. But another really cool thing about Albireo is one of these stars is a lot heavier than the other. One of the stars is about 15 solar masses, so 15 of our own suns put into one. And the other star is about 4 solar masses. So how like orbiting works in space is instead of just orbiting about each other like this, the barycenter, like that center of mass, is more towards that 15 solar mass star. So the 15 solar mass star will kind of move a little less than that 4-massed star, but that'll move around it. I would love to see the Andromeda Galaxy, but I do not believe he is up tonight. M61, I see Eric asks. Let us try to grab M61. Cool, so he's a galaxy. So we're messing with our settings right now. So since this is a galaxy, we're gonna up the exposure time a little bit. Messier 61. So this will be okay. So it's a spiral galaxy. It looks like a barred spiral galaxy. That's nice. The nucleus of that galaxy is very bright. So we're gonna edit the settings a little bit. And yeah, so we can, oh, that's nice. Yeah, you can see those really bright star forming regions. And that S shape, that spiral shape. It's a very visible spiral. That's nice. I would love to see Saturn, Amanda, but I believe we have to wait a little bit longer for it to come up. But we will try in a little bit. Alan asks for M92. I believe that guy is a globular star cluster. So I think it's a very dense globular star cluster. Yeah. So we'll jump back over to him. Now, there are a bunch of different clusters of stars in the sky. The main two types of clusters, there are globular star clusters as well as open star clusters. Globs, as I explained earlier, the very sciencey science word globs. Whoa, that's cool. Oh my gosh. Wow. I like that. I don't think I've looked at this one recently, but wow, that is cool. Okay. Globular star clusters, as I mentioned previously, those are like hundreds of thousands of stars really tightly bound together and kind of orbiting about each other in a little glob. So you can see just how dense that center of that globular is. You can't even make out individual stars with how close together they are. That is so neat. Oh my goodness. Thanks, Alan. I like that. Open star clusters, on the other hand. Open star clusters form the same way as globulars do. However, they are usually less stars. So rather than hundreds of thousands of stars, there's only tens of thousands of stars, which is still a big number, but significantly less than globulars. And since there's less stars, there's a less of a gravitational pull between these stars, and these stars slowly drift apart from each other because of that weak gravitational pull. So that's why they're called open clusters, because they're drifting apart from each other. Now, this drifting takes, again, millions of years. You don't see the stars moving away from each other, but it's kind of like the opposite of a glob, where these globs are bound together really tightly. Those open clusters are more sparsely packed. Okay, M92. M81 was requested. Let us try M81. So Messier 81, we're going to try to jump on over to him. We resetted our exposure time, so we're not gonna travel light speed this time. It's very sad. So Messier 81, is this another? Oh no, are we in a cloud? We're gonna try to see what's going on here. Maybe it was a weird exposure for a second. Oh, we're actually aiming towards the roof. So you may have seen the telescope move, and the roof is just behind it. We're looking at that, so we can't quite see this guy tonight. I apologize. Now I see K9SB. What is that guy? So we have the right ascension declination in the chat. Are we able to grab him? So he's a comet. Ooh, okay. So if he's in the sky tonight, I believe we will be able to see him, unless he's behind the roof. The very poorly placed roof. I'm kidding. The entire plaza is really insane. We have all 6 of those telescopes, which you may be able to see in the view there. And then that building behind, that building actually moves. The building acts as like a roof. So the building will slide on tracks to cover all of the telescopes during the day, or if weather conditions don't permit viewing. So the whole facility is really cool. It's really neat. So we're going to try to jump on over to this comet. I believe that he is actually not behind the roof, so I think we should be able to see him okay. Usually comets will appear as a star, but with a little fuzz around them. So we'll see if we can grab him. Nice. Oh, cool. Okay. Nice. Okay, so you can actually see in the field of view that those stars are way brighter, more pinpoints. And the comet is a little fuzzball. So we talked about asteroids earlier. How I like to tell the difference between the two is asteroids are kind of like wet rocks, and comets are just dirty snowballs. So comets come from further outside of or on the edges of our solar system, and asteroids are kind of in the center almost. The asteroid belt is just between Mars and Jupiter. It's all these little rocky bodies, and these comets usually come from the Kuiper belt. So that's hundreds of thousands of little icy bodies that'll sometimes come through our solar system. And the reason why we see that fuzz is because that ice is subliminating. So it's turning directly from that solid state to that gaseous state. So we see that little fuzz going around. And when you look at like pictures of comets, you're seeing the same thing there, those comet tails. That's what's happening there. Now, we have a lot of requests. How exciting. Okay. So Bill McDonald asks for M51 and then the negative view. Okay, I think we're able to do that. Let's see, M51. M51 is my second favorite thing to look at in the entire sky. My first favorite thing is the Orion Nebula, but he is not up. I'm very sad about that. The Whirlpool Galaxy is just one of like the coolest things I've ever seen. Like, it's okay. So it's a spiral galaxy. We're going light speed towards them right now. We're seeing that little star across the screen. The Whirlpool Galaxy is a spiral galaxy about 23 million light years away. The galaxy is a little over half the diameter of the Milky Way, so it's like 60 light years across. And what we're seeing is galactic cannibalism. So we're going to try. So just we're able to see what looks like two galactic centers. Oh, nice. That's good. That looks really good. Wow. See what I mean? That is so cool. So what we're seeing is galactic cannibalism. So that larger galaxy on the top there is actually eating that smaller galaxy at the bottom. You can see that's cool. That's the negative. So we can see not only with visible light, but like also with the negative light, you can see those star forming regions, those spirals. Those really dense star forming regions there. And you can see how dense those galactic centers are. So since that main galaxy is so much more massive, it is eating the smaller galaxy. Where the galactic, that's just so metal. I don't know. I think that's just the coolest thing. Now, let us see. I got very excited. Sorry, I'm calm. Okay. Sorry. Okay, M51. Request from Christian Pittman to see M33. Oh, Ryan asked, what's my favorite phenomenon to observe? I'm sorry, I totally missed that. Favorite phenomenon. While we're jumping over to oh, sorry, M33 is triangulum. We can't see him. M61. Can we grab M61? We're going to try to jump on over to him. He has an active supernova, according to Keith. I'm expecting to see the supernova. My favorite phenomenon. Yeah, I just like the Orion Nebula. Like, something about it is just so cool to me. Like, when seeing the Orion Nebula through the Clark telescope made me want to cry, and then seeing the Orion Nebula through our 32-inch telescope at the Open Deck Observatory made me cry. I cried. I just like, I think not only like the okay, that's nice. We got him in there. I believe this is oh gosh, M61. Okay. Oh, the supernova is to the left here. So we can see that supernova in M61 there. Yeah, I just think nebulae are so cool. I think they're so pretty, and the concept of star forming regions is just like so cool to me. I don't know. I just like, I could look at them all day. Are we able to see the Cat's Eye Nebula? Yes, we are. Okay, let's jump on over to him. So the Cat's Eye, I believe, is a planetary. So similar concept to the Ring Nebula and the what was it? Oh my gosh, the Dumbbell Nebula that we saw earlier. So we are moving the telescope. We're taking that exposure, a little less of an exposure. Cat's Eye. Oh, I haven't seen that in a long time. Man. So we're gonna take this exposure real quick. Ooh, he's a bright guy. Yeah, so we're gonna zoom in, maybe down the gain a little bit, or yeah, exposure time. So I believe it was either the Cat's Eye Nebula, the Helix Nebula, or both. Got really or got imaged very nicely with the Hubble telescope. It's like one of the coolest images was I think it was the Cat's Eye Nebula. I think that one is pretty cool. Now, this guy, looks very dense, very small, and pretty far away. So we're trying to, oh, nice. We can just barely get it. We can see that white dwarf in the center there. So we can see the white dwarf, not quite Hubble quality, but sadly we are not in space. I wish we were. Uh, so you can see that white dwarf in the center, and you can see all of that gas being erupted off of that white dwarf there. Okay, Cat's Eye. I believe was the Beehive? Beehive is not available. I wish it was. I'm sorry. The Beehive is an open cluster. It kind of looks like a beehive, which I think is very weird. With things like the Wild Duck cluster, the Beehive cluster, it's like if you squint, it all looks like a beehive. But whatever. I wasn't on that committee. That's fine. Alpha Centauri. Is Alpha Centauri okay, Alpha Centauri is too low. What we can do is we can try to grab Saturn. We'll be finishing up here in a little bit, but I would love to try to grab Saturn before we head out here. Amanda asked what my favorite star is. I like Betelgeuse. I think Betelgeuse is really cool. Nice. Oh, yay. Okay, so we're gonna mess with the exposure a little bit. Those three dots that we see right there, those are actually some of the moons of Saturn. I think there's one off to the top left as well, unless that's a smudge. Okay, anyways, getting real close to the screen there. Yeah, my favorite star is probably Betelgeuse. I've already said it twice, so I can't say it again. But it is a red supergiant star, and it should be the next star in our night sky set to go supernova. So either tonight, tomorrow, or in 10,000 years, it'll explode, and that'll be kind of cool. It's not in the sky tonight, though. I wish it was. Saturn. Okay, so we're on that video mode again, because if we take it too long of an exposure, as we saw earlier, it kind of blows out the image. We're able to see those rings of Saturn, a little bit of atmospheric turbulence in there, but we can still see him pretty okay. He's kind of waving. He's lower in the horizon right now, so we're getting a little more atmospheric turbulence than like straight up, you know what I mean? Yeah, Saturn's about a billion miles away from us, so further than Jupiter. We were able to see some of his moons there as well. I think he's neat. He looks like a little bug in telescopes. Now, my favorite constellation. Probably Draco. Draco the Dragon's my favorite constellation because it's a dragon. I don't know. I think that's cool. And like Hercules is standing on his head. Nice. So we can see all of those moons. The brightest moon in there is Titan. I think it might be yeah, right there, down there. Titan. Titan's pretty cool. Titan and Earth are the only two things in our solar system that have liquid on its surface. Titan, or Earth, we have liquid water. Titan has liquid methane. Yeah, I think that's pretty cool. All right. So with that, thank you guys so much for all of your requests. We tried to get to all of them that we could. Again, thank you guys so much for joining. If you would like, we do have a bunch of these interactive stargazing activities, usually like once a week. We also have a bunch of live streaming opportunities. Specifically Saturday, July 4th, we have the prenumbral lunar eclipse live stream and interactive stargazing. So if you'd like to look at other things, or if we didn't quite get to your suggestion, we can definitely try to do that then. So it's at 8 p.m. Arizona time, or 8 p.m. MST. So thank you guys so much, and I hope you have a great night. Stay safe.